getting the slant asymptote of a rational function, and that is our case number 3, right? Again, when you say case number 3, that means the degree of the numerator is more than the degree of the denominator. But how do we get the slant asymptote? Well, the slant asymptote should be the quotient, again, quotient, not the remainder, right? When ax over bx, meaning the numerator and denominator is given, will be divided, right? You can use long division or synthetic division for such. Okay, let's now answer that one. Let's try number 31. Okay, so in number 31, we have the following. Get the slant asymptote of the function f of x is equal to 4x squared minus 10 all over, what's this? 2x minus 4. Are we good, guys? Right. So first of all, let's notice the terms first, right? Or the numbers. 4, negative 10, 2, negative 4. What do you notice about these numbers? Anyone? They're all even, which means, very good, that's correct. Eva, that means they're all divisible by 2, right? So in short, you can further simplify first by taking off or taking out the common factor, right? Which is 2, get it? So with that being said, we can further simplify this one and just write it as 1. 2x squared minus 5, very good, all over x minus 2. Get it? Okay, so again, if you see that the terms or the the coefficients at least are what? Divisible by a certain number, that means they have a common factor, which means you can further simplify them before doing the synthetic division. It's gonna make it simpler for you guys, okay? Because the smaller the numbers are, the more manageable it is, okay? Next one, what do we do then? Well, we look at the degree. What's the degree above? What's the degree of a, or the numerator? Magnolia? What's the degree of the numerator? 2. Very good, right? Very good. What's the degree of b, or our denominator? Aiden, what do you think? Is the degree of our denominator? 1. Very good. 1, right? That means 2 is greater than 1. So yes, it's case number 3. Are we good? Right? Good, guys. So with that being said, let's do now our long division or synthetic division, right? So it doesn't really matter which one you prefer. Let's try to use the synthetic division, right? So synthetic division. Look at our, what's this? Divisor box first. What do we put on our divisor box? The x minus 2. Very good, Candy. And what do you do with that x minus 2?
You solve it.
Solve it by what? Equate it to what first? 0, right? And yes, we're going to solve it from that, right? What x value will you get from here? Anna?
2.
2. Very good. What's the next step? What do you do with the dividends? Right? Dividend. The terms that's being divided. Write it in what form, guys? Standard form. Very good. Okay. Consider the coefficients, right? And if there are missing terms, we make it what? Zeros, right? So very good. So with that being said, this is now what? Well, that's 2x squared. There's no x. And a constant negative 5, right? So again, if there's missing terms, set it to 0 as placeholders, right? So we put them as follows: 2, 0, negative 5, okay? We put a bar. Okay, let's do this. Ready, guys? Let's do this. Okay. What's the first thing that we're gonna do for such? Giselle, what do you think? What do we do with the 2?
Bring it down.
Bring this down. Very good. That's correct. Okay, next. What do we do next from there? Candy, what do we do with this 2 and that 2? multiply, and the product put where?
Maybe
Under the 0, right? Very good. The next column. And what do you do with these two? 0 and 4. Madeline?
You
You add
add them.
them together, right? So once again, it's different from long division because long division you subtract. In here, you add, right? So 4. And do the same thing until the end, all right? You good? All right, let's continue with this. Logan?
I multiply 4, 2, and get
8 and put it in here. Got it? Okay. Last one. What we're gonna do? What we're gonna do with these two values in here? All right, Olivia. Add them, and that's gonna be 3. Get it? According to our case number 3, what are we interested in terms of this? We want just the what? Just the quotient, right? So we don't consider the remainder, we just want the quotient, right? So what is the quotient here? What numbers represent the quotient? Anyone? Emma?
2 and 4.
2 and 4, very good. That's gonna be what? 2x plus 4 for your quotient. Are we good, guys? Alright, so again, your quotient is always 1 degree less than that one in there, right? And that is gonna be what? Are we good, guys? And I think in here, since we actually divide everything here by 2, right? And that's the denominator, I would say that you divide everything here by 2 as well. Hence, turning this into what? X plus 2 instead. Okay, now let's see. Is that actually the slant asymptote? Well, let's verify it by graph. Good? Right. So let's verify it by graph, right? Let's put it in here, like such. Ready? Okay. So let's graph the function first. Here it is. It says what? 4x squared, here we go, minus 10, right, all over x minus 2. Okay. See that graph over there, guys? Good. 4x squared minus 10 all over, 2x minus 4. 2x minus 4. See that graph over there? Okay. Now, let's see the slant asymptote. We said that's what? Y is equal to x plus 2. Alright? So it's not the x plus 2. It might be the one a while ago, the 2x plus 4. Let's try the 2x plus 4 first. 2x plus 4. Okay, so it does look like it should be the 2x plus 4 instead. Okay? Are we good? Right? So I guess because we have already simplified that one in here already, right? That means you don't need to divide it by 2 anymore. Are we good? All right, so with that, we are going to erase this one in here and just focus on the 2x plus 4 instead, okay? Are we good, guys? Right, so again, the graph in here is slant asymptote at 2x plus 4. Are we good? Questions? Right? And again, the last thing that you're going to do is to verify it by graphing. Questions?